Now, instead of using our long division method, sometimes we might be requested to use to find the remainder, okay, without evaluating the quotient. Okay, so the long division method, although it's a little cumbersome, it enables us to find not only the quotient but the remainder as well. So suppose we are given a polynomial, we should find the remainder only when it is divided by a particular divisor. Okay, so how do we go about that? So let's say we are given, so what we want to consider is the remainder theorem. Okay, now let's say we are given a polynomial of, let's say, f of x is equals to 2x raised to power 3 minus 3x squared plus 4x minus 1. And once we wish to find the remainder when it is divided by divisors x minus 1, b, x minus 2, and c, x minus 3. Now, we can use the long division method as we have in our previous video, where we do 2x raised to power 3 minus 3x squared plus 4x minus 1, and then we have x minus 1 here, or instead of x minus 1 we can have x minus 2 to find the remainder, or have x minus 3 to find the remainder. So what if we don't want to go through this route? Okay, what if we want to just find it directly? Okay, so how do we go about that? That's the question. How do we go about that? Now, when the divisor, okay, now let's consider one. When divisor is equal to, when divisor is x minus 1, so we say x minus 1 is equal to 0, and our x will be equal to what? 1. And all we just have to do is substitute our x to be equal to 1 in the polynomial of f of x. So that means we have our f of x is equals to 2x raised to power 3 minus 3x squared plus 4x minus 1. And then we want to find the remainder when our divisor is x minus 1. So that means we're saying f of 1. Okay, so we just do substitute x to be equals to 1, 3 minus 3 into 1 squared plus 4 into 1 minus 1. So that will give us 2 minus 3 plus 4 minus 1. And this in total should give us 2. Now, let us, okay, now let us substitute. If you try, the true thing is that if you try our division method, I think we can just quickly do that. So we want to divide 2x raised to power 3 minus 3x squared plus 4x minus 1. I want to divide it by x minus 1. So let's quickly do this together as we have done before. So we divide 2x raised to power 3 divided by x. We have 2x squared. Multiply 2x squared all through by x minus 1. So we have 2x squared minus 2x squared. This is 2x cubed, sorry. And it's 2x squared. So we subtract it. Okay. So this will give us 0. 2x cubed minus 2x cubed will give us 0. Minus 3x squared minus 2x squared will give us minus x squared. And we drop down the rest, that's plus 4x, okay, minus 1. Okay, so then we go again the process, that's we are dividing minus x squared with x, so we have minus x, so we multiply minus x with the whole of the divisor, so we have minus x squared and plus x. Okay, and we subtract again, so this will give us so we know that this whole end will give us 0, right? And we have to subtract 4. We have to do 4 minus 1, so that will give us 3x. So drop this one down, minus 1. So we divide 3x again with the first term of the divisor, that's 3x divided by x, right? So that will give us plus 3, and we multiply plus 3 with the whole of the divisor, so we have 3x minus 1. And when we do this, we'll have okay, 3x minus 3, sorry, okay, so minus 3. So when we subtract it again, and then we'll have what, 1 minus minus 2, so that will give us 1 minus minus 3, that will give us 2. So we can see that this is our remainder, just like we have, and this is our dividend, and this is our quotient, just as this is our divisor. Okay, so then afterwards we realize that the answer we have here is the same as that we have here. Okay, so it is very simple. So the rule is very simple, the theorem is very simple. So if you can write it that if the polynomial f of x is divided by x minus a, abi, then the remainder is f of a. Okay, now I think we have two more questions that we've just done a, and let's go back and do b and c. So when the divisor is x minus 2, right? So we just equate x minus 2 to be equals to 0. So my x will be equals to what? Will be equals to 2. Okay. Now the next thing to do is to substitute and evaluate f of 2, right? So f of 2 is equals to what? And we recall that our f of x, as we have here, is or like we have here, 2x cubed minus 3x squared plus 4x minus 1, 2x cubed minus 3x squared plus 4x minus 1. Okay, so then we substitute of f of 2. So f of 2 will be 2 into 2 cubed minus 3 into 2 squared plus 4 into 2 minus 1. And now give us 2 into 8, right? Minus 3 into 4 plus 8 minus 1, and this will give us 16 minus 12 plus 8 minus 1, and our answer will be 11. So the remainder is 11, right? And let's do the last one. When the divisor is x minus 3, so we just equate x minus 3 to be equals to 0, so my x is equals to 3. So we are looking for f of 3, right? And we call that our f of x is 2x raised to power 3 minus 3x squared plus 4x minus 1. So we substitute 3, so our f of 3 will be 2 into 3 raised to cube minus 2 into 3 squared plus 4 into 3 minus 1, and this will give me 2 into 27 minus 2 into 9 plus 12 minus 1, and this will give me 54 minus 27 54 minus 18. Yes, this is 3. Okay, minus 27 plus 12 minus 1, and this will give us 38. So the remainder there is 38. Okay, now a question might come in that what if some people say, what if it is not in the format of what if it is in the format of, let's say, x minus 1 or x minus 2 or x minus 3? What if it is in the format of let's say 3x minus 1? So if it is 3x minus 1, we just equate 3x minus 1 to be equals to 0. So our x will be equals to what? 3x is equals to 1, so our x will be equals to 1 over 3. Okay, so then all we just have to do, is to substitute our 1 over 3 into the equation, right, and get our answer. Now the theorem, okay, the theorem whose proof we have just established is called the remainder theorem. So in general, if f of x, now you can just write a general, if f of x is divided by ax plus b, then the remainder is f of minus b over a, because we just have to equate this divisor to be equal to 0 and find an expression for x. Okay, and our x from here will be minus b over a. What we'll have here is what is inside here. Okay, so as a special case of the remainder theorem, when f of x leaves no remainder when it is divided by x minus a, we therefore say that x minus a is a factor of f of x. Okay, and the modified theorem is called the factor theorem. Okay, and then we say that if, okay, now this is the general format of the remainder theorem. Now let's talk about the factor theorem. Factor theorem. How do we know if a divisor is a factor of the dividend? Because we had something to do like that when we evaluated the remainder to be equals to 0. Okay, we add the remainder to be equals to 0. Okay, in this case, we said at this point that 2x squared x squared minus 2x plus 4 is a factor of x cubed plus 8. Okay, how and why? Because if, say for instance, say f of x as a polynomial is divided, okay, by x minus a, right? So that means our remainder, right, is equal to what? F of a, right? Because when we equate x minus a to be equal to 0, we have x to be equal to a. Okay, and eventually, if our remainder, okay, that means f of a is equals to 0, then x minus a is a factor of f of x. So we can be requested to find the remainder of something using the remainder theorem, and we can also be expected to find the factor of a polynomial given a divisor. Now let's take an example. Let's see number 4. Okay, now the question says that show that x plus 1 is a factor of f of x is equals to 2x cubed plus 3x squared minus 5x minus 6. Okay, now we realize that this is our divisor and this is our dividend. Now we want to apply the factor theorem. So to establish the factor theorem, okay, we know that x plus 1 is equals to 0. Are we? So our x is equals to what? Minus 1. So we have to evaluate f of minus 1, okay, as the remainder, right? So that means my f of minus 1. So I'm going to apply my equation here. So wherever I see x in this equation, I substitute it for minus 1. So that means 2 into minus 1 cube plus 3 into minus 1 squared minus 5 into minus 1 minus 6. So this will give me 2 into minus 1 plus 3 into 1 minus 5 into minus 1 minus 6. So when we multiply out, we have minus 2 plus 3 plus 5 minus 6. Okay, and our answer will be 0. Now since our remainder, okay, remainder, right, is equal to 0, and from the proof that we had here from the factor theorem, it says that if f of a is equals to 0, then x minus a is a factor of f of x. So that means if our divisor, that means x plus 1, yeah, when it is divided by this, we add a remainder of 0. So therefore, hence, okay, x plus 1 is a factor of f of x. Okay, so we can also use long division method to arrive at this, but we'll just try one more example. Let's say 5. The question says find the remainder. Say find the remainder when f of x is equals to 2x cubed plus 3x squared minus 4x plus 1. And when it is divided, okay, divided by 2x minus 1. And it says as what is the conclusion? Okay, so we know that this is our divisor, right, and this is our dividend. Okay, so in conclusion, we have to find the equate this to be equal to 0, and our x there will be 1 over 2. So all we just have to do is to find f of 1 over 2, right? Remember our f of x is this, so wherever we see x, we substitute 1 over 2, right? So our f of 1 over 2 will be equals to 2 into 1 over 2 cube plus 3 into 1 over 2 squared minus 4 into 1 over 2 plus 1. And this will give me 2 into 1 over 8 plus 3 into 1 over 4 minus 4 into 1 over 2 plus 1. And this will give us 1 over 4 plus 3 over 4 minus 2 plus 1. Okay, and 1 over 4 plus 3 over 4 will give us 1 minus 2 plus 1. So all these will give us 0. Now we can see that our f of 1 over 2, which is the same thing as our remainder, is equals to 0. And if the remainder is equals to 0, that means we know that our divisor is a factor of the dividend. Okay, so that's how it is. So when the remainder, in conclusion, okay, what is the conclusion? The conclusion is that the divisor, okay, in conclusion, all we are saying is that 2x minus 1, in conclusion, 2x minus 1 is a factor of f of x. Okay, so we can draw a general conclusion that if the remainder is equals to 0, divisor is a factor of the dividend. So to wrap up this topic on polynomial, we would look at something called zeros of polynomials. Zeros of polynomials. Now, when we are given a polynomial and we are asked to find the zeros, okay. Now, the zeros of polynomial means the values of x for which the polynomial f of x is equal to 0. So all we just have to do is to equate the polynomial to be equal to 0. So let's take examples. Okay, let's take examples. So it says find the zeros of the polynomials. We are given two polynomials. Let's say we're given two polynomials. A, p1 of x is equals to x squared minus 5x plus 6, and b, p2 of x is equals to x squared minus 1. Right, and to find the zeros of polynomial, we just have to equate the polynomial to be equals to 0. Right, so a, so we just have to say put p1 of x to be equals to 0. So we equate this polynomial to be equals to 0. So therefore we are having x squared minus 5x plus 6 to be equals to 0. So all we just have to do is just to solve it as a quadratic equation. Okay, we solve it as a quadratic equation. So when we solve this, let's use the factorization method. So we have x squared minus 3x minus 2x, okay, plus 6 is equals to 0. So to factor this out, we have x minus 3 and x minus 2 is equals to 0. So x is equals to 3 or x is equals to 2. Now in the second question, so it's as easy as that. These are the zeros. Okay, these are the zeros. X is equals to 2, x is equals to 3, or x is equals to 2. So we put p of 2 of x to be equals to 0. So here that means we are having x squared minus 1 is equals to 0. So it's easy. So we can say x squared is equals to 1 and x will be equals to square root of 1. And we know that square root can be plus and minus. And so our x will be equals to plus 1, right? Or minus 1. So the zeros of the polynomials x squared minus 1 are x and x is equals to plus 1 and x is equals to minus 1. Now there might be questions that come around like what if we are given something of x raised to power 3 and we have to find the zeros of the polynomial, and this is something that has to do with solving polynomials of degree 3. Okay, so I think we'll talk this later on in the video, but not for this polynomial segment, later on, and we'll talk deep on how to solve polynomials of degree 3 or even polynomials of degree 4. So just let me give you an hint. The first thing is to find a factor of the polynomial, and we will try different values. Okay, it can be x equals to 1, x equals to 2, or x equals to minus 1, or x equals to minus 2, until we get that the remainder is equal to 3. Or in short, all we just have to do is to factorize, as easy as that. So factorize the cubic equation and then we have a solution. This might be by completing the square method or even using the quadratic formula, as the case may be. So this marks the end of polynomials. Thank you very much.